All right, let's get into it. Today, we are basically going to give your code a brain. We're talking about Python conditionals. These are the tools that let your program stop just, blindly following a list of commands and actually start making some smart decisions on their own.
So just think about this for a second. What if your code could only ever follow one single path? I mean, just doing the same thing over and over again, no matter what. It would be pretty useless, right? It's like having a GPS that only knows how to get to one place. Not very helpful.
Well, that rigid, one-way street has a name. It's called control flow. It's literally just the order your code runs in. But our whole mission today is to break out of that straight line. We're going to learn how to bend it, how to create forks in the road, and really open up what our code can do.
And how do we do that? With conditionals. You can think of a conditional as a gatekeeper standing in the middle of your code. It asks a really simple yes or no question, and depending on that answer, it opens up a specific path for the program to follow. This is how code begins to think.
So here's the plan. First, we'll start with the absolute basics of how code thinks. Then we'll build our first simple yes-no decision. After that, we'll get into handling more than two options, combine those into some complex logic, and finally, we'll see how this stuff is used out in the real world.
Okay, let's dive right in. For a computer to make any kind of decision, it needs a system. And you know what? That system is incredibly simple at its core.
It's kind of funny. At the end of the day, every decision a computer makes, no matter how complicated it seems, just boils down to two simple answers, true or false. That's it. These are called Boolean values. Is the user logged in? True. Is their password wrong? False. Everything, and I mean everything, gets simplified to one of these two.
So now that we have our true and false, we can build our first decision maker. This is that classic if this, then that logic that really is the backbone of, well, pretty much all programming.
Okay, here it is, the if statement. This is our workhorse. Think of it like a gatekeeper. You tell it, hey, if this thing is true, and if it is, the gate opens and lets the code run. And the way Python knows what code is behind the gate is super important. You need that little colon at the end, and then you have to indent the next lines. That indentation is absolutely key.
But what if the condition is false? What then? Well, that's where else comes into play. It's the default path, the otherwise option. If the if condition isn't met, the program just naturally takes this other route. So together, if and else create a perfect fork in the road for your code. And these are the tools we use to ask our questions. These are the comparison operators. This is how we find out if something is true. Is x equal to 5? Is the temperature less than 0? You're going to be using these all the time to build your conditions.
Now, I need you to listen up because this is the #1 mistake every single person makes when they're starting out. Look at this. If x equals 5. That single equal sign, that's not asking a question.
That single equal sign is telling Python to make x equal to 5. It's an assignment. What you really want to do is ask a question. And for that, you need the double equals. If x equals 5. That's how you compare things. One equal sign assigns, two equal signs compare. Please burn that into your brain.
A simple yes or no is great, but let's be real. Life is usually more complicated than that. What if you have 3, 4, maybe even 10 different outcomes? For that, we need a bigger tool.
And that tool is elif, which is just short for else if. It lets you chain a bunch of questions together. So the code asks the first if question. If that's a no, it moves on to the first elif and asks again. It'll just keep going down the line until it finally gets a yes, and if it never does, it hits that final else at the end.
So how does Python actually think its way through this? It's pretty straightforward and honestly kind of lazy in a smart way. It starts at the top with the if. Asks, is this true? If the answer's no, it just moves on to the next elif. How about this one? True? Nope. Okay. Next one. The very second it gets a true, it runs that block of code and then it just stops. It completely ignores everything else in the chain.
Okay, now we're taking a huge leap. We're going from asking one simple question at a time to asking multiple related questions all at once. This is where your code's logic can get really sophisticated. These are our logical operators. And is super strict. Both things have to be true. Or is way more relaxed. It's happy if just one of the things is true. And not is the simplest of all. It just flips whatever you give it. Turns a true into a false and a false into a true.
All right. Now, this is a really cool kind of Pythonic shortcut that pros use all the time.
Python has this idea of truthy and falsy values. Basically, some things are just naturally considered false in a conditional, things like the number 0, or an empty string, or an empty list. So instead of having to write something clunky like if len of my list greater than 0, you can just write if my list. How cool is that? If the list has anything in it, it's truthy. If it's empty, it's falsy.
All right, we've got all the pieces of the puzzle. Now, let's put them together and see how this all works in actual professional code that's out there in the world.
Here we go, a super simple login system. This is a perfect example of that AND operator. You need the username to be correct and the password to be correct. If both of those things aren't true, you're not getting in. It's a fundamental pattern you will see absolutely everywhere.
And I'm not kidding when I say it's everywhere. This exact kind of logic is the beating heart of so many systems you use every single day. Logging into a website, a security system deciding to unlock a door, an automation script deciding if it should process a file, it all comes down to this.
So as you start writing your own code, let me give you a quick cheat sheet of things to watch out for. Forgetting that colon or messing up the indentation, your code just won't run. Simple as that. We already hammered home the equals versus double equals thing, but these last two are more about writing good code. Trying to nest if statements inside other if statements over and over again gets messy fast. My advice, keep it simple whenever you can.
Look, if you walk away with only one thing today, let it be this. The whole thing we just talked about, it all comes down to this one simple idea. Every if, elif, and else is just there to ask one question. Is this true? And based on that answer, the code knows exactly which path to take. That's it. That's the secret.
So there you have it. You now have the absolute fundamental tool for making your program smart and reactive. The possibilities from here are, literally endless. So I'll leave you with this. Now that you can actually control the path your code takes, what's the first thing you're going to build? Thanks for joining me, and happy coding.